M2, we're thrilled by the success that's happening on tour, but all along our job was to make it better, right? And in this case, where M2 is defined by creating incredible distance and incredible forgiveness, and doing it in a way that's a little bit more simplified than the M1, so a little bit less intimidating to some who don't need all the adjustability. And so for us, challenge to make it more forgiving and go farther and all of that was a tough task.
It all starts with we wanted to save more weight on the carbon crown on both the M1 and the M2, and we did that by going from 7 layers down to 6 layers, which was a big savings percentage-wise. But at the same time on the M2, we have a lot of titanium still left on here, and we've been working for over 20 years on trying to make titanium better, thinner. We were still looking for, can we get more weight out of it? Because we're pretty much down to minimum thickness. We're thick thin on the sole everywhere we can go. And we've been working for several years now on a new breakthrough titanium alloy that's going to save even more weight. And we were finally able to qualify that. I mean, you look at the progression of golf club design over, since metal woods came out, it's pretty much been about making things lighter, making portions of it lighter so we can free up weight to move that mass to where we want it.
I want to get into the geoacoustic side because we talked about the materials, and the other side that really is unlocking this forgiveness is the geometry, this intelligent geometry that is so visible in the bottom of this M2 driver. You see a shroud that comes over from the top. You see this sunken area in the toe. And typically, you don't raise the sole of a club, especially a driver, because you're trying to keep the weight down.
I mean, the main goal of this head was to make it larger, and so we needed to free up volume somehow. So we sink the toe up into the head, and when you move mass up, you want to do it with as little mass as possible. So we utilized the thick, thin tie structure that we've previously done with the 911 material and applied the honeycomb structure to the bottom of the head. So when you move all that mass up into the head, you're doing it with as little as possible. And that frees us up to take all that extra mass and move it to an area that's ideal in terms of performance. In terms of volume, it allowed us to make the head bigger, the face larger, the address size bigger. We were able to scoop out that extra area. It's just like mass, like you're able to scoop out the extra volume and put it in a place that you want to see it.
I think that's an incredible breakthrough in the sense that now you're sitting down, you're looking at a bigger head, so it looks more forgiving. You have more surface area, from the face. All of that sort of came to life through that technique. And then the acoustical side of it. It's like we plowed through this door of innovation as it relates to the geometry, and then all of a sudden we have these other incredible benefits.
So one of the things that as we were shooting for getting more volume out of the head, basically hogging volume out of the sole to get a bigger head, is a drop sole portion here with some curvature that is smaller than the original sole shape. And what that did for us is it makes a stiffer structure. Therefore, we were able to have good sound, good quality sound coming from the sole without having a ton of ribs, which we needed for the other inverted shapes or other irregular shapes of this sole portion.
We're trying to find this balance of form and function where we're breaking through with this geometry and the acoustics, and then we want this thing to look incredibly good. And so that came some other challenges.
The big challenge for us was this toe area. What we wanted to be very respectful for what the engineers had worked on. Very smooth surface. We didn't want to add a lot of geometry. Okay, so we do, it's going to add ribs, it's going to add weight, which is going to hurt performance. So our challenge is to work around this area to find a solution that accomplishes, make it look good, make it look compelling, and keep performance at the highest level. So we ended up doing, I don't know, maybe 30, 40 different variations of decals out here just to try to find a solution to make it look great.
We've talked a lot about this freeing up mass and making the head larger, and the one part that's also very visible in the head is this back weight, because this product is hopefully telling the golfer a story and what it does. It frees up all this mass from the crown. They look at it now, a big forgiving head with a bigger face. Even the weight we save from the thick, thin tie in this sunken sole section is all put down and far back in the head. So down far back in the head creates typically a lot of forgiveness, right? Big sweet spot, but also high launch and high spin. And so we want to create high launch and low spin with all that forgiveness. So that's where, this speed pocket, which was originally introduced in rocket balls, and we've iterated and improved and evolved this technology into what is now this M2 driver. And Dave, I know, with this, we're able to kill some spin and protect some ball speed, but expand on the work that you did and the team did on the speed pocket.
Absolutely. At least 30 iterations, maybe 30 or 40 iterations early on of different speed pocket shapes, sizes. We iterated on the length of the channel, the depth of the channel, the thickness of the walls, how far the channel is from the face. We tried to study this speed pocket from every aspect that we could. I feel like we optimized it. We nailed it. We've got it. The thickness is optimized, so it's durable, but it performs. We've made leaps and bounds since the original M2 as far as performance and deflection. I think we're deflecting about 3 times more than we were on original M2, and we have higher ball speed on low face hits. So we've done a lot of stuff here to really make this a high performing product.
We talk about M1 being really the most adjustable product that we have, but the M2 is also adjustable in the driver. It has the loft sleeve. It has the new aluminum loft sleeve, 12 positions.
The loft sleeve is one of the most important features in a modern golf club. We've had it since 2009. And basically the way it works is it's at a 2-degree angle as it comes out of the hosel, right? So the shaft is basically at an angle, and as you take this out and rotate it, the shaft goes at a different angle relative to the base hosel as you move that around. So we have 12 different positions with the 2 degrees.